In this video, we'll write the balanced net ionic equation for NaOH plus Zn NO3 2. This is sodium hydroxide plus zinc nitrate. The first thing we need to do is balance the molecular equation. I can see I have a nitrate group here and two of them here. So I'm going to put a 2 in front of this sodium nitrate. Once I do that, I have two sodiums. So I'm going to put a 2 in front of the sodium hydroxide. Now I have two sodiums. Those are balanced. Two hydroxides. But I have two hydroxides here. So we're all done. That is the molecular equation. Next, we write the states for each substance. Sodium hydroxide, that's a strong base. It's going to dissolve and dissociate into its ions. Nitrates are very soluble. That'll also be aqueous. We have sodium nitrate here, so aqueous. And then hydroxides, in general, they're not soluble. There are some exceptions. Sodium hydroxide is an exception. Some of the other elements in group 1. But most of your hydroxides aren't soluble, so that means it's going to be a solid. It won't dissolve in water, so we write S. So these two react, we will get a precipitate, this zinc hydroxide. Now we can split the strong electrolytes into their ions for the complete ionic equation. Sodium's in group 1, has a 1 plus charge, the whole hydroxide, 1 minus. Two sodium ions, 2 Na plus. I won't write the states right now, let's write that at the end. Plus 2 hydroxide ions. And then for the nitrate ion, that's 1 minus for the whole thing. We have two of them, so 2 minus, we need a 2 plus for the zinc. And in fact, the zinc ion, zinc is always 2 plus. And then we have the 2 nitrates. And these are the reactants in our net ionic equation. For the products, we said plus and minus, so we have 2 sodium ions again. And then we also have 2 nitrate ions. For the solid here, the zinc hydroxide, we don't split solids apart in net ionic equation. So it's just ZnOH2. That's our zinc hydroxide. So this is our complete ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. They haven't changed, so we're not really interested in them. So in the reactants, I see 2 sodium ions. In the products, I see 2 sodium ions. And then in the reactants, I have 2 nitrates. And here again in the products, 2 nitrates. Let's get rid of those. And what's left, that's our net ionic equation for NaOH plus Zn NO3 2. I'll clean this up and write the states in. We'll have our net ionic equation. So this is the balanced net ionic equation for sodium hydroxide plus zinc nitrate. You'll notice that we have 2 times the 1 minus. We have 2 minus here and a 2 plus. They cancel out, so we have a neutral substance here. You'll also note that if you count the atoms up, they'll be the same on both sides, so mass is conserved as well. Sometimes with these net ionic equations, you'll see the positive ion first. It doesn't really matter, it's the same net ionic equation. It's just you'll see this way more often. This is Dr. B with the balanced net ionic equation for sodium hydroxide plus zinc nitrate. Thanks for watching.